Alright y'all, here's a super quick raw vid on complex numbers because I'm about to head in and see y'all. So, recall that really there's only two things that you need to know, and that is that I'm defining I as a square root of -1, and therefore square root of -1 times the square root of -1 is just -1. I times I is I squared, so I squared is -1. If you know those two things, I feel like you've actually got most of the stuff in the bag. So if you're given something that looks pretty complicated that before you didn't know how to break down, you can go ahead and do your tree for that and have, let's see, 54, 9, and 6, and then you can break it up some more. But then there's always this -1 factor, right? So when you actually go through and you circle your leaves, you'll see that while a pair of 3's come out, you'll be left with a -1 and a positive 6 inside. This square root of -1, by definition, you're never going to leave written like that anymore. You're going to change it into I. So this becomes I, and as you can see, these guys cancel, and you get -I root 6. Now I tend to write the roots at the end. Usually mathematicians will do this, and I actually think that it's just because we don't want to get confused with what's actually inside of the square root, so we just leave it until the end. Okay, let's do another one so that you can actually see that it's easier to solve these than you think. As soon as you see that negative inside, you should know that you can just, in effect, think about it as if you're taking out an I. Then you can break this up. This one is 5 and 9. So you get -I 3 root 5. You don't really leave it in that order. You usually put the number first. And there's another quick problem. Okay, another kind of problem that you'll see is actually seeing I expressed to some power. So let's try, I don't know, 35. So here again, I want you to remember that I squared is -1. And recall that if you take I, or -1, and you square it, you get a +1. But if you get -1 and you cube it, you get a -1. And so forth, right? If you keep going to the 4th power, to the 5th power. So, to summarize, if you're taking it to an even power, it becomes positive. And if you're taking it to an odd power, it becomes negative, right? So, let's go back and look at this problem. I kind of like to think about this again as like dating. So I'm going to say that this is not, it's an odd number of people. So I'm going to take out the 3rd wheel that does not need to be there for any dates to happen. And these guys are going to break down into how many couples? Well, let's see. That would be what, 17? 17 couples. Now that 3rd wheel is still out there kind of alone. But now you can make use of your I squared being -1. And you see that you have taken I squared to an odd power. -1 to an odd power. Therefore, this just becomes -1 times I, which is just -I. Remember, we also summarized our solutions for this kind of problem. You're only ever going to get one, -1, I, or -I. Those are your only 4. If you get something else, you've done something wrong. Alright, we also kind of graph these. that say? Remember that we are graphing the real portion on the x-axis and the complex portion on the y-axis. So that means that you're going to take whatever coefficient was in the real portion of your complex number, and that's going to be your x, and then your imaginary portion is going to be your y. So you go there and give yourself a dot, and you're done. I'm going to call this example A, because we saw that sometimes you get things that are a little bit stranger. So we saw sometimes I would just get something like 4i, right? Well, what does that mean? That means there's technically a 0 in front of here, so I'm not going to go anywhere in the x direction, but I am going to go up 4. I'm going to go there, and that is B. Okay, also kind of works in the reverse, right? So if you have a number that's just like 3, well, that means there's technically a 0 here, so you're really only going to go in the x direction 3. So that's graphing. Now we also introduced a big concept called the complex conjugate. And if you remember, we kind of tried to tie this concept to the fact that if you had like a plain vanilla parabola, it would cross the x-axis twice, usually, unless it was a double root and bounced. But even there's two solutions to a quadratic, right? It crosses the x-axis twice, there's two roots, there's two solutions. So even if you had something that was imaginary, and again, this is only kind of like a visual representation of imaginary numbers, you should know that there's always going to be a pair. So if there's let's say that there's a 9 plus 3i, there's also going to be a 9 minus 3i, right? So always realize that there's a complex conjugate, in other words, the pair, and you always do that by just making the complex portion of the number the opposite sign. So even if you're tricked or like they attempt to trick you, right? That root 3 does not change, right? It's real. As ugly as it is, it's still real. So you only change the sign of the complex portion. Now, we took this idea and actually had stuff like a rational or complex number here. We had division, right? And much like we would not like, I don't know, something that looks like this, and I would not like a root in the denominator, I'm not going to want an I in the denominator. Why? Because I am a root. In other words, you know I is the square root of a -1. Now you're never going to write this anymore, but you're going to realize that I is a root, so you don't want to leave it in the bottom. So you're going to multiply by that concept we just learned, the complex conjugate. And again, this is the mathematician trick of multiplying by 1, right? This is just a fancy way of saying 1, right? So make sure that your top and your bottom match. I saw that not happening in some of y'all's work. So now you're just going to simply distribute as usual. So 2 times 1 is 2, 2 times 2 plus 2i, or 2 times, yeah, plus 2i is 4i. Alright, keep going. 3i, 6i squared. And let's do the same at the bottom. 1 plus 2i minus 2i minus 4i squared. And this is where you kind of have to, remember your adding like terms, but also remember the big thing, one of the two big things, I squared is -1, right? So you're never going to leave an I squared in one of your problems. So this really amounts to 2 plus 7i plus 6 times -1 plus, oh, sweet. So minus 4 times -1. And then you have, this is a plus 6 or a minus 6 now. So 2 minus 6 minus 4. Notice that order matters. I tried to put the real part first. And then you get 1 plus 4. Well, that's just 5. And I will ask, you're going to see like express in a plus bi form on your exams. I do ask that you break this apart into real and imaginary. Now I said, oh sweet, but this is going to always happen with the complex conjugate. You're not going to completely cancel out the denominator, but it is going to become real. So you're always going to get a fraction like this. These i's should always cancel if you multiply correctly by the complex conjugate. And I think that's probably the worst of the problems that we got. So good luck!